go down, I'm moving down. There are sample questions. All right. I have for this one, chapter 5. So if you go there, you can see questions I'm going over.
This is stuff you were doing today?
We done it last class. We did half of it done. Okay. I worked out. Do you see in the red my workout for calculations? How I get the answer in there?
Do I see what?
For example, do you see question 12? A scuba diver typically begins.
Yes, sir.
So I have explained in red letters how you get answer. Do you see it? Now, what I want you guys to go through is, I have gone through some of the problems in detail. All right? Those are the important ones that you have to look at wherever there's red color here. Those are the important questions.
Yes,
so
sir.
What you do is when you are studying, just go through them and make sure that you understand calculations shown in these. Not all of them are done here, only important ones. Okay, like.
Okay.
So you do it for chapter 6 also. Let me go to chapter 6, because chapter 6 is the one I'm going to talk about today. Going back. The test's going to be on Monday or Tuesday. All right? I'm going to send you email about the timing. So I am going back to the questions under module 3. If you look at here for chapter 6, this highlighted chapter 6 is there. Do you see where it's highlighted? My cursor is moving. Do you see 105 chapter 6 PowerPoint question and answers? Now this is the chapter 6. I'm clicking on it. So what you do for chapter 6 is same thing you do for chapter 5. Okay? When you go down, this is the introduction room. Okay. They have similar. I have worked out. Most of them are conceptual questions. I'm going to go through some of them today, but I'm going to show you what is important. What is in calculations are the most important thing. Normally, conceptual questions you can understand. If you're going down on this, I have some problems. I'm going there. Like this. You see that red? They are the ones that you have to go through. Okay? So I have picked up important calculations like that. So then some of them are under below. So just like in chapter 5, you have to go through them. Okay?
Uh-huh.
That will cut down your lot of work. Make sure that you understand how to do these calculations. You understand?
Uh-huh.
So there are some dilution problems. Let me show you some of them. These dilution problems, okay, you need to go through them also, how to calculate, okay?
Uh-huh.
At the end of the chapter, there are few questions, calculations. I am only giving answers to calculation. Calculations are like colligative properties. There are few calculations. Do you see here?
Uh-huh.
So when you go through these files, go into web page, you will see these are in red. Those are the ones I have explained how to calculate. Okay?
Okay.
For example, if you get a problem, similar problem, you should be able to deal with it. Okay? So I haven't put a lot of questions, only few questions. Okay? Now, today I'm going to go through chapter 6, conceptual questions. All right? I'm going to go to 6 slides. Can you see it now?
Yes.
Okay, I'm going to, I have gone over chapter 5, half of it. So you have to go through conceptual questions and calculations I have shown in the chapter 5. Today I'm going to go some of the chapter 6 conceptual questions. All right. Let me start. Now, introduction to mixtures. Which of the following is a solution? A solution is a homogeneous mixture. Blood plasma is not homogeneous. It has large particles. Cigarette smoke is not solid and a gas, is smoke. Milk is not a true solution. It's a colloid. It's not a solution. So none of these are solution or mixtures, homogeneous mixtures. Therefore, answer is D. Which of the following are intermediate between homogeneous and heterogeneous mixtures? Heterogeneous mixtures is one extreme. Homogeneous is another extreme. Homogeneous mixtures are uniform throughout. Heterogeneous mixtures have different composition. So in between is suspensions. Alloys are homogeneous mixtures. Solutions are homogeneous. Plastic could be homogeneous or heterogeneous. But the suspensions have solute particle size greater than 100 nanometers. Their particle size is greater than colloids. So suspensions are in between homogeneous and heterogeneous boundary. That's why it's intermediate. It's called intermediate between homogeneous and heterogeneous. In a solution, solvent is present in large amount. The substance present in the greatest amount is the solvent. we talked about in our slides. A solution may contain only one solvent, but many solutes. Only one solvent and one solute. Many solvent, but one solute. Many solvent and many solute. Normally, solution has only one solvent. Rest of the components in the mixture are in a small amount. Therefore, many solvent, many solute, only one solvent, and many solutes is the correct answer. A solution will have one component that's called solvent, but you can have minor components in small concentration, many solutes. Therefore, answer is A. Which of the following can serve as a solvent in a solution? A solution is not just a liquid mixture. It is any combination of gas in a liquid, liquid in a liquid, solid in a liquid. Therefore, all these can act as a solvent if present in large quantities. To which of the following solvent-solute combinations apply to alloys or metallic solid mixtures? So alloys are metals dissolved in metals in solid state. Therefore, they are solid-solid. You look for solid-solid. Metallic means two metallic solids in a homogeneous mixture. Therefore, C is the answer. Which of the combination will always result in a solution? Which of the combination will always produce a homogeneous mixture? Only gases can mix in any amount, any gas, but any solid liquid is limited. They're depending on solubility. But gases are soluble in the soluble means goes to no homogeneous mixture. Therefore, answer is gas and gas. Liquid and liquid sometimes doesn't always form homogeneous solution. They make layers. Solid and solid also sometimes don't mix up. Which of the following terms is used to refer to a gas dissolved in a liquid? Gas dissolved in a liquid is solute. So it's not a solvent. Liquid means it's major component. So answer is C. Which of the term used to refer to a liquid component in liquid solution? Solid also in a liquid solution is a solute. Solid, they are not asking about solid. What is the liquid component in a solid in liquid solution? Liquid solution is, liquid component is solvent. Which term is used to refer to a solid component in solid liquid solution? Solid component is solute. What is the solute when alcohol is dissolved in water? Alcohol is put in a small amount in water. Therefore, alcohol is solute. Solute is the alcohol. Okay, there's more choices. The compound present in small amount is a general, more applicable. This is only for alcohol. So D is the general and most descriptive. A crystal of solid sodium chloride is placed into aqueous sodium chloride solution. Most but not all crystals dissolve. The means original solution. Now we have to decide between saturated, supersaturated, or unsaturated. It is observed that most but not all. Most gone, but not all. That means it's a saturated solution. Unsaturated. It is kind of confusing. It observes that most but not all of the crystals dissolve. There's no choice for that. B is the only thing there, correct? Which is not an example of a solution. Chicken noodle soup is homogeneous, heterogeneous mixture. That's the correct answer. I am going to go to a little bit, these are kind of questions that let's go to this. Which pair of compounds will form a solution? Benzene and hexane. These are organic compounds. They are non-polar compounds. In the choice B, sodium sulfate and organic compounds are, one is ionic, other one is organic. Third choice C, one is inorganic, one is ionic, one is organic. On the choice D, water is polar, carbon tetrachloride is non-polar. So only similar compounds will go into solution together. Therefore, only solution that is similar here is A. Organic goes into non-polar. So A is the correct answer. Now, what interaction responsible for chloride ion going into an aqueous solution? Ion dipole. Hydrogen atoms in the water is a dipole on the water molecules. Dipole interaction with chloride ions on the hydrogen atom water. Hydrogen atom has positive charge. That should be the correct one. Dipole in the oxygen is negative in the water. Therefore, C is not the correct answer. Hydrogen bonds between chlorine ions and water. Normally, chlorine doesn't make hydrogen bonding with oxygen. So answer is only B, dipole attraction between chloride ions and hydrogen atoms in water. Like dissolves like. It's not adequate. It's not enough to predict solubility when the solute is an ionic compound. Non-polar compound, easy to find out. Polar compounds, easy to find. But ionic compounds are separate category. Sometimes we cannot say ionic compound is a polar compound. Ionic compound is ion, polar compound is only separation of charges. Ionic compound doesn't apply to like dissolves like, but they are more like polar. Which of the following types of ionic compounds are most insoluble in water? Group 1A, like lithium, sodium, potassium ions, we said salts of ionic compounds of those are soluble. They're asking insoluble. We remember some hydroxides are not soluble, some chloride. So answer for some insoluble in water is chloride, hydroxide. Which of the ionic both they are soluble in water? We remember silver nitrate is soluble, silver chloride is soluble, sodium hydroxide is soluble, potassium sulfate is soluble, both pairs soluble in water. So the answer is B. Sodium ions, ionic compound with sodium cation, potassium group 1A, they are soluble. So answer is B. I'm going to skip some of these. They are about the solubility of ionic compounds. Methanol is insoluble. Both are polar compounds. Heptane is insoluble on water. Water is polar, heptane is non-polar. False, it's not soluble. Barium ions combine with, to produce an insoluble salt. Nitrate salts are soluble, therefore that's false. So there are few questions about the solubility. Saturated solution contains excess undissolved solute. That's true. Vitamin D is tested for its solubility in water and benzene. It is found to be soluble in water and soluble in water and soluble in benzene. The solubility indicate vitamin most likely be a non-polar compound. So if it is a non-polar compound, it's not going to be soluble in water. So therefore it should be false. Oh. Vitamin is soluble in benzene and found to be insoluble in water. Therefore it is most likely to be non-polar. I didn't read the question. Insoluble in water is it cannot be polar. So it's non-polar is the correct answer. A solution contains maximum number of grams of solute that can dissolve in solvent is said to be supersaturated. Maximum number is unsaturated, saturated. That's false. Fat soluble vitamins have polar molecular structures. Fat is non-polar. If fat vitamins are soluble in fats, they have to have non-polar structure. Therefore, that's false. So go through some of these and you will work out few problems. What is the solubility of table salt in water at 30 degrees Celsius? Salt in water is 30, is about room temperature. So what is the solubility of salt? 200 grams, 16 grams, 32. I think it's highly soluble. C. So 36. I'm not sure. You had to look up in the table solubility. In which of the following combination of miscible apply? Miscible apply to liquid. Which of the following properties does the expression like dissolved like generally refer to considering solubility in a solvent? Formula weight, no. Molecular shape, ionic weight and molecular shape. Formula weight, neither formula weight or molecular shape. Like dissolved, right. Is molecular shape sometimes affect polarity? Therefore, it could be B, neither molecular, neither molecular weight or molecular shape. None of them apply. Solubility of liquids and gases. Gases increase with temperature, decrease with temperature. Solubility of liquid solid in liquids increase with temperature. Which of the following will increase the solubility of sodium chloride in water? Increase in the temperature is the answer. Which of the following will increase the solubility of oxygen gas in water? Decrease in the temperature. A is the correct. Decrease in the temperature and increase in the pressure. Both A and D. There are two answers. Therefore, E is both A and D. Increased temperature decrease the gas solubility, and increased pressure increase the gas solubility. True. Henry's law is a pressure solubility relationship in gas in liquids. Henry's law is like ideal gases have laws. Gases in liquid follow Henry's law. Which of the following terms can be used to quantitatively describe the concentration of a solution? All of them. 500 millimeter salt water is prepared by dissolving 200 grams salt. What is the percent weight by volume? So 20 divided by 500 milliliters. 20 divided by 500 is, let me do the calculation. 20 divided by 500 multiplied by 1. 20 divided by 500 is 4%. I did the calculation. It's 4%. Now, here these are the examples that I want you to go through. How you calculate this. I could get the answer. I cannot just look at and give the answer. I had to work it out. So I worked each one of these important questions about concentration. That's what I was showing previous web page. These are the ones that you need to carefully see how you calculate it. So this is concentration units, percent unit. Some of them are molarity. Molarity is defined as moles per liter of solution. So I haven't calculated everything, but some of the important ones like these, you need to read, slow down and do the problem like this. Try to understand. I start with the definition. Molarity is equal to moles divided by liters. Then I get the moles from the question for 4.40 grams. 4.40 grams divided by molar mass of KSCN. I get the moles. Then I plug in the moles divided by liters. They have given the solution, 340 milliliters. Converted to liters is 0.340. Then I get the molarity of 0.133, the choice D. So this is what I am talking about. I have calculated some other percent concentration problems here. You have to go through them. You cannot talk it through. You have to kind of work out. So I haven't done all of them because they are similar. I haven't done them because they are kind of same idea. Concentration in it. So this is the dilution problems. Now dilution problems are important. You start with the molarity, higher molarity solution and add water. Dilution means adding water. So you get two solutions. M1 is the initial molarity of the solution. V1 is the volume of the solution. M2 is second after molarity after adding water. V2 is volume of solution, of dilute solution. V2 is always, for dilution problem, V2 is greater than V1. M1 is greater than M2. Therefore, these two are M1, V1 is equal to M2. On these problems, I label where the V1 volume is the final volume, initial volume, what volume needed to. M1 is the initial molarity. That's to prepare 150 milliliter solution. And this is the M2 second molarity. So you plug in, you get the number of milliliters. Question is, what do you start with? How many milliliters? If you look at 11.7 millimeters are now 150 milliliters. After dilution, you add more solvent until 11.7 become 150 milliliters. So these are similar problems about molarity, the dilution problem. These are similar problems. This is dilution problems. We talk about ppm and ppb. We are not going to ask questions about ppm and ppb, except the definition, no calculations. Water is a good solvent because it has hydrogen bonding capability. Because of that, it has high specific heat. low boiling point, high surface tension. Hydration applied to the solids. We are not talking too much about solids. Therefore, don't worry about solids and crystals. We are mainly talking about solutions and solubility of salts and electrolytes. Electrolytes are the ones that break up in water to produce ions. If ionic compound breaks up completely in water, it's a strong electrolyte. It breaks up in small amount is called weak electrolyte. Electrical conductance is used to measure how much ions are in the solution. Higher the number of ions, more electrical conduction, therefore more conductivity. For example, 228, which of the following will have highest electrical conductance? These are sodium chloride is completely break up in water. 1 molar solution and 2.2 molar. 1 molar, 0.2 molar is concentrated than 0.1. Acetic acid, this one, is a weak electrolyte. They don't break up. Therefore, these two are not producing that much ions in the solution. Therefore, it's between 0.1 molar sodium chloride or 0.2 molar sodium chloride. Because 0.2 molar sodium chloride has more ions, it has the highest. B is the correct answer. So there are other questions like that. Highest electrical contact. That's the same problem. That's potassium chloride. Potassium chloride is like sodium chloride. Therefore, answer is B also. Which of the substance is non-electrolyte? This breaks up into ions. This breaks up in water to ions. That breaks up. But this doesn't produce ions. Hydrogen peroxide breaks up to water and oxygen. They don't produce ions. Therefore, it's not an electrolyte. All of the following strong electrolyte except. This is a acid that break up completely in water. Sodium hydroxide, all these breaks up except this acetic acid. B is not a strong. In the order of solution electrical content, it may contain ions. In order for a solution to conduct electricity, a solution like water only conduct electricity when ions are dissolved in it. Which of the following take place when HCl? It breaks up to hydrogen ion and chloride ion. Hydrogen reacts with water. Resulting solution is strong electrolyte. That's true. Hydrogen reacts with water and resulting solution is a strong electrolyte. None of these. HCl reacts with water and resulting solution. That's the correct answer. HCl is a strong electrolyte. What happened to glucose when it dissolves in water? It doesn't break up. Break means dissociate. It dissolves into ion, no. It forms covalent bond with the, no. It forms hydrogen bond with, no. Yes, hydrogen bonding takes place. So, the answer is not shown here. Answer is C. Which of the following is true of colloidal particles? Colloids are homogeneous mixtures with solute particle size is greater than 1 nanometer. 1 nanometer is, and it also scatter light. The solutions are like homogeneous milk, whitish. The light doesn't pass through. Therefore, smaller than 1 particle and scatter light are the correct answer. They are greater than 1 nanometer, not therefore only scattering. I said, I didn't read the question. Colloids are greater than 1 nanometer. This is also wrong. Greater than 1 nanometer. Which of the following examples of a colloid is when gas is dispersed in liquid? Whipped cream. Whipped cream is a gas dissolved in water. When liquid is dispersed in liquid, liquid in mayonnaise. Which of the following solid dispersed in liquid? Jelly. Which of the following factors cause colloidal particle to remain without settling? So they are not attracted to each other. Particles don't settle. Colloidal particles solvent are the same size. No, that's not true. Colloidal particles have larger solvent layers. Colloidal particles solvent are the same size, and colloidal particles have large solution layers. Cause the colloidal to remain. I think colloidal particles have solvent molecules. Colloidal particles have large solution layers, probably prevent them. Either B and C. So I go for B. Right, B is the correct answer. Which of the techniques can we separate colloidal dispersions? Addition of solvent that have great affinity for water, it removes the water from the colloidal particles. Then they aggregate, they separate out. So these are about colloidals. Which of the following is a colligative property? Osmotic pressure. Osmotic pressure is one of the colligative properties. Other is freezing point depression, boiling point elevation. There are 3 main ones that we are focused on. Which of the following will have the lowest freezing point? Then colligative properties defined as properties of solvent solution that depend on number of particles in solution that count the ions or molecules. So if you have the same molar mass, like here, sodium chloride produces 2 ions, this produces 3 ions. It breaks up to 2 ions, sodium chloride. Therefore, barium chloride. So, but this produce same molarity, this produce 4 ions. 1 aluminum ion, aluminum 3 plus cation, and 3 chloride ions. Therefore, C has the highest, C has the lowest freezing point. Lowest freezing point means depression. So C has the lowest drop in the, which of the following has the lowest freezing point? All are same concentration. They don't break up in water. Therefore only same number of particles. Therefore all will have the same. Now freezing point depression, boiling point elevation. So now the solution, how you calculate freezing point depression, I have explained here. If you dissolve 215 grams of methanol, methanol has a molar mass of 32. Molar mass is all the atomic masses added up in the molecule is 32. 215 divided by 32 gives 6.72 moles of methanol. When dissolved in 100 grams of water, so if 1 mole of a substance dissolved in 100 grams of water, freezing point depression is 1.86. That means negative 1.86 Celsius for every mole. So there are 6.72 moles. So calculation is 1.86 multiplied by 6.75. I calculate the number of moles and multiplied by negative 1.86, I get 12 point. That's the correct answer here. So that's how you calculate. Boiling point elevation also has similar calculation. So this is another example where freezing point depression is lower than that. So water freezes at 0. Therefore, depression is always negative. 0 minus depression. 0 minus 0.93 gives 0.93 Celsius depression point. So I have calculated for another problem. So you guys look at this carefully. This is again boiling point elevation. That constant is 0.502. Freezing point elevation per mole is 1.86. So according to this, number of moles of methanol is same as in the previous one, same 213 gives the same answer, number of moles here. So then you plug in the equation, get 3.5. Now here's the question. Boiling point is 100. Elevation means 100 plus. Therefore, real boiling point of methanol solution is this. In this case, since it's 100, depression becomes just negative number. Here you have to add to 100 degree boiling point elevation. So I have calculated some of the problems. You go back into in the web page, you read the questions. If you find them anything that calculated, it might be important. So go through them carefully. All right, I am going to stop the class for today. I will send you email describing what time to take the test. All right, you will get email in your Canvas email. All right, I'm going to stop the class for today. Are you guys there?